All right, Cassidy. Tell me one thing that you guys would consider as evidence for continental drift. What about the landscape? What would you hope to find? What do you mean it's the same? Come on, complete the thought. Well, I mean, okay, guys, so let's talk about this as a group, right? You guys had the landscape. Well, what do you mean by the landscape? Okay, so we should have similar landscapes set on both sides. Okay, all right. So let's go on to another group.
I knew it.
No. Abby, what did you guys come up with? Plants and okay, so looking at fossil records. And what would you hope to find then?
Those are the same animals on different planets. Okay, I'm really tired.
I know it's first block, we got to put our thinking caps on.
Okay.
Go ahead.
So, like, there's like the same type of dinosaurs raised on different continents, and they're across the ocean. They can't swim over, so they were connected at one point.
Some can.
Because they can't swim over there. That's really important. No, honestly, I know it seems like kind of ridiculous, but that's a really important statement. All right, and we're going to talk about that today as well. Okay. Oh, go ahead, Tracy.
Rocks.
What about the rocks?
There are similar rocks in different countries. Like, really showing in the video.
Similar rocks in different countries or different continents? Different continents. Okay. So, all right. Now, hold on. I want to put this all together. You guys actually just came up with the exact thing that Alfred Wegener set out to find. Fossil records. Rock records. Looking at the features on both continents. What about the oceans? You gotta remember that really all the oceans are is just the filler. That's it. It fills the open spaces. Okay. Now there's actually one more that you guys did not come up with, and that's fine because it's kind of a hard one to think about, and that is looking at climate change. Looking at climate data on different continents. In fact, one of the strangest things, and again, we will see this again later in the notes, one of the strangest things that Alfred Wegener found was coal on which continent? Where do you think he found coal that was so strange that he found the coal?
Antarctica.
Why would you say that, Bree?
Because it's cold there.
Yeah. So why can't I have coal where it's cold?
Because there's not very many animals there. It's cold made of fossil.
There you go. Coal is typically found in two regions, swamps and tropical rainforests, right? Because you had to have tremendous amounts of biomass decaying in order to be compacted into coal. So basically, he actually did find it on Antarctica, underneath the ice sheets. And that actually tells us a lot about the continent of Antarctica and the fact that it was not always ice covered. It was not always at the south. Okay? It had to have been moved. So these are the theories or the evidences that Alfred Wegener went ahead and collected. That's what we're going to look at today. So his big theory of continental drift was very simple. He proposed that at one time all of Earth's continents were one giant landmass. And he called that landmass Pangea. So I'm glad you guys all know what Pangea is, although very few of you guys have told me what it actually was. And as we already had that discussion in class, you guys already came up with the different things that you would use to support this theory. So one of them Well, definitely the rocks samples. You have the fossil record. Similar features in terms of geology. And then the last one, which is really important, is again looking at the climate.
What like height of like cliffs or whatever, like around the ocean boundary?
Not so much because there's so many things that could actually affect. You could have strong currents and weather systems that would actually erode faster on one area than another. So that would not necessarily be the case.
You never mind.
And so again, we can see this transition here more as a static. We showed you guys the animation earlier. This is more as a static change as we go from Pangea breaking away into our current status today. So, again, we're going to kind of look at this, looking at Alfred Wegener's idea, and we're going to go ahead and take a look at rock formations. Now, one of the things I want you guys to understand is, when we look at the time period for Alfred Wegener, we're talking about the turn of the century. Okay, so we're talking about early 1900s. So we're not talking about fast travel here. You're still talking about to go from the U.S., or sorry, to go from New York to L.A. is close to a week by train. Okay, so this is taking a while. It's still a 2-week trip to get across the ocean. It's not until the 1914s, or 1914-15, that we finally had ocean steamers that could go from London to New York in about a week. So we're still talking a very long time to travel. And so when you think about Alfred Wegener, keep in mind that this guy was a scientist who spent his life going out and researching and trying to get more evidence to support his theory. And so this is really an accumulation of information over his entire lifetime. So what he starts finding out is when he starts traveling around to different places, he notices then that rocks in the Appalachians match Europe, right? And we saw a video on Thursday talking about Loch Ness, about how some of the rocks from Loch Ness actually match up with the rocks from the Appalachian Mountains. Okay, and that's basically what we're talking about right here. And we can also see that pieces of Greenland match rocks from the Canadian Shield, despite being separated by almost 1,000 miles of open ocean. And then what he also noticed is that if you go to the east coast of South America and the west coast of Africa, the two rocks again are the same. And so that's why, again, looking at the rock formation to make sure they're the same, and we notice that they're the same. Then he looks at animal fossils. And this is kind of important, because there's two types of fossils to look at, just like what Abby said, plants and animals. And I don't know about you, but this big guy right here does not look to be a strong swimmer. So I doubt that he somehow could swim from Africa to South America, roughly about 3,000 miles of open ocean. Don't think he's going to make it. So when we look at these, and we see that we have multiple fossils of each one of those animals, and then we find them on both continents, it starts to definitely suggest that there's no way that these animals could have possibly crossed open ocean. Therefore, either the continents had to have been closer at one point in time, or had to definitely be connected at one point in time. Now, another one that's kind of important here is the Mesosaurus. Which, when you look at the Mesosaurus, what does it look like to you guys?
A lizard.
A lizard. Or even possibly an alligator, like a small little canyon, right? And again, kind of important to note here is you're not going to find these guys in open oceans. But where do we normally find alligators and caimans? Yeah, shallow waters. So again, findings on both continents, again, suggests that you're not going to see them in open ocean. You're going to find them more in your shallow waters, maybe lagoonal. And so that's one place there. Your book talks about some of the plant fossils as well, specifically looking at ferns. And that's, again, something that's worth reading. So one thing that you guys might want to do for your homework tonight is to actually read through chapter 17. And chapter 17 is basically what we're going to be working on for the rest of this week. So there's a